Okay guys, this is going to be a video on everything that we've done in the huge topic of surds. So the first thing that we learned in this module was how to simplify surds. And if you remember, the way that I taught you to do that was to do a factor tree diagram. I'm going to do one of these for you, and then I want you to pause the video and do the remaining 6, and then press play and check your answers. So I'm going to do 700 because that looks a bit harder than some of the other ones. And if you remember, what we do with these is we start by writing a factor tree for 700 to find the product of prime factors. Okay, well, looking at this, I can see that I've got 7 and 100. And 7 is a prime number, so I'm going to need to circle the 7. And now I can continue with 100. Well, 100 is 10 times 10. And 10 isn't prime, so I can keep going to get 2 and 5 and 2 and 5. Easy enough. We were all able to do factor trees when we did this in the lesson. Now, if you remember back to the lesson, the decision was then, which numbers do I take when I then square root it? Right, let's have a look. We've showed that 700 is 2 times 2 times 5 times 5 times 7. So that means now when I square root 700, I've got a square root of all of these numbers. So now I'm square rooting 2 times 2. I'm square rooting 4. So I only need to take one of these 2's out to take it outside the square root sign. Now I've got another pair here. I've got a pair of 5's. So I take out one of those 5's because the square root of 25 is 5. And that leaves 7 left inside the root. This is our surd. 2 times 5 is 10. So we've ended up with 2 root 7. That is now fully simplified. This can't go down anymore, and I've simplified my surd. Press pause and see if you can do the others, and then I'll put the answers up for you. Okay folks, so there are your answers for those first 7 questions. Okay, moving on. Now we're going to have a look at what to do when we are asked to add or subtract surds. Now this is now like algebra. You've got something, take away something, and the two things are completely different. You cannot add or subtract surds when they are the same thing. So what you've got to do is simplify your surds first and foremost before you can do anything at all. So again, I'm going to do number 1, and then you can have a go at the others. Press pause and see if you've got the answers correct. So here we've got root 48 take away root 27. So I need to find out what root 48 is. So I'm going to do a little factor tree for root 48. So 48 is, well, 6 times 8. This becomes 2 and 3. And this becomes 4 and 2. And 4 is 2 and 2. So now when I root 48, I need to find all my factor pairs. So I've got 2 of those and another pair there. So that's 2 multiplied by 2. So that's 4. And left on their own, when I look at my different pairs, all I'm left with is a 3. So 4 root 3. Now if I do root 27, see what that is. Well, when you simplify root 27, you will see that you've got 3 root 3. I know I've done this right because I've got root 3 take away root 3. The question would never ask me to do something where there was a root 2 left here and a root 3 left here, because you couldn't take them away. Now we've got the same thing. We've got 3 lots of root 3's and 4 lots of root 3's. So now root 48 subtract root 27 is the same as 4 root 3 take away 3 root 3. So this is a little bit like having 4x take away 3x. So if I've got 4x take away 3x, I'm just going to have, well, 1x, which we'd say is x. So in this case, I've just got 1, not x, but 1 root 3. Just treat your surds like roots, like x's. So 4x take away 3x is x, so 4 root 3's take away 3 root 3's just leaves you with 1 root 3, but we don't say the root 3. Right, pause the video and check your answers and see how you do. Okay, so here are your answers. Number 1, we've got root 3. Number 2, we've just swapped these around, so now we're taking away something that's bigger. So we've got 3 root 3's take 4 root 3, so we've got minus 1 root 3, so minus root 3. 10 root 5, minus root 2, 10 root 3, 12 root 2 for number 7. Number 8 is 9 root 3. Number 9 is 12 root 2, and number 15 is 15 lots of root 3. Good. Right, now let's get on to some harder questions. We're asked to express 6 over root 2 in this form where a and b are positive integers. Now what they mean here is to rationalise the denominator. Whenever we see a root in the denominator, we know that we have to get rid of this root sign. And this is just telling me that this is what my answer should look like. So I'm going to write out the question, 6 lots of root 2. And remember, whenever you're being asked to rationalise the denominator, it means we're not allowed a surd on the bottom. So we need to multiply by whatever you've got here. And because we don't want to change the size of the number, we need to multiply by 1. Therefore, we're going to multiply by root 2 over root 2. So now we've got 6 lots of root 2. So that's 6 root 2 multiplying the top by the top. And now we multiply the bottom by the bottom. Root 2 multiplied by root 2. Well, that's just root 4, or if you like, 2. Now don't forget to fully simplify, because here we've got 6 divided by 2. So we can sort that out. 2's going to 2's once, 2's going to 6 3 times, and we can see that we've got 3 root 2. And that would be worth quite a lot of marks on the paper. And all we've really got to remember is this important step here. Right. Now we're asked to expand and simplify, and we've got this bracket squared. Always, 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 when asked to expand any kind of bracket with a squared sign, write it out longhand. So I've got this bracket multiplied by this bracket. If you don't write it out, you'll do something daft and forget some terms. Now when you're multiplying out 2 brackets, you always get 4 terms. We're going to have a go at doing this by the grid method. So I'm going to just draw a grid. So I'm multiplying root 3 by root 15 and root 3 and another root 15. So that's one bracket multiplied by the other bracket. And now I'm going to fill in my grid. So root 3 times root 3 becomes root 9, or 3. Remember, when we're multiplying inside the square root sign, we can bring it all inside the same hat. So root 3 times root 15 is just root 45. Now I can sort that out in a minute. This is root 3 times root 15, so this gives me also root 45. And root 15 times root 15 just gives me 15. Now before I can go any further, I can see that I probably need to sort out my root 45. So I'm going to draw a quick factor tree for 45. So that is 9 multiplied by 5. 5 is a prime number. 9 is 3 times 3. And 3 is a prime number. So when I square root this, I'm going to get anywhere I've got a pair can come outside my square root sign. So 3 times 3 means I can bring 1 3 out, and leaving inside is the root 5. So this can be rewritten as 3 root 5. So I'm just going to change that in there and rub that one out there, and do the same thing there, and pop in 3 lots of root 5. 3 lots of root 5. Now I can add my terms together. Notice my answer, I've got to get a number plus a number lot of root 5. So I can see that I've got 3 add 15. I can combine like terms and add my numbers. So that would be 18. And now I've got 3 lots of root 5. Add another 3 lots of root 5. Well, that's just 6 lots of root 5. 3 add 3. 6 lots of root 5. And I'm all done on what would be quite a hard question seen towards the end of the paper. Right, here we've got another one. So press pause, you have a go, and then press play to follow how I have done it. Right, well on this one, I don't need to write it out because they've already written it out for me. So all I need to do is set up my grid. I'm doing 2 plus root 3 multiplied by 1 and another root 3. Set up my grid. Okay, now we can fill in my grid. 1 times 2 is 2. 1 times root 3 is root 3. 2 times root 3 is 2 root 3. Root 3 times root 3 is root 9, which is 3. The square root of 9 is 3. Now I can summarise by combining like terms. So I've got a 2 and a 3, so that's 5. So A is equal to 5. And then I've got 2 root 3's, add another root 3. So if that was x, 2x and another x, I've got 3x. So add 3 lots of, they're not x, they're just root 3's. 5 add 3 root 3. Right, here we go. Here we've got one with a negative. Okay, so let's just have a go at one with a negative. So I'm going to draw my grid out. Oops, daisy, I don't want that. Go away. Okay. Draw my grid, and I'm multiplying, so I'll put that in there. Okay, so this bracket is 2 plus root 3, so I'm going to put 2 plus root 3. Oh, I keep pressing something on the pen, sorry. Keep clicking something by accident. And then this bracket is 7 take root 3, so I'm going to put that on here. So I've got 7, and then I've got a minus root 3. Remember, I'm timesing, so now I can just times everything across. So 2 times 7 is 14. 7 lots of root 3 is just 7 lots of root 3. 2 times minus root 3, well this is a positive times a negative, so I'm going to get negative 2 lots of root 3. A positive times a negative here means I'm going to have a negative. Root 3 times root 3 is just 3. Now I can combine my like terms. I've got 14 take away 3, so that's 11. And I've got 7 root 3's take away 2 root 3's, so that gives me plus 5 lots of root 3. And that's how to do everything to do with surds.